If you're building a game in Godot and you want your map to be built using tileable, reusable assets, you're going to want to use a TileMapLayer. Tile maps exist in all sorts of games, from chess and Settlers of Catan all the way to StarCraft, Diablo 2, League of Legends, and more. Today we're going to be doing a deep dive into TileMapLayers, explaining how all the various settings work and how you can easily use them in your game. Hi, my name is Brian, I'm a software developer, and I'm taking that love of software development and moving into game development. My goal is to make a bunch of easy to understand tutorials so that you know how to use the tools that are available to you to build the games that you want. Let's get started. Okay, so the first thing we're going to do is just set up our project for some pixel art. So let's come into our project settings, under the project menu, make sure that advanced settings is turned on. We're first going to go to rendering 2D, and enable snap 2D transforms to pixel. Next, we're going to go to rendering textures and change the default texture filter to nearest. Next, we're going to go into our window settings under display. First thing we're going to do is change the viewport width and height. We want something that's a multiple of 16 by 9. I'm going to pick 640 by 360. Then we're going to come down into our stretch mode, change this from disabled to viewport. And we're going to change our window width and height to something that works for your monitor. In this case, I'm using 1920 by 1080. Okay, so when you first load in a TileMap layer, you're going to see a new panel at the bottom labeled TileMap, and it's going to tell you that the edited TileMap or TileMapLayer node has no TileSet resource. So this is typically where we would be selecting individual tiles to paint on the screen. However, because we haven't defined a TileSet, there's nothing for us to do here. So we need to do that first. Now, what is a TileSet? Well, it's a collection of tiles, and so these are either defined as a atlas, which is a sprite sheet that is broken up into various chunks, or it can be a scene collection. So this can be a bunch of other scenes that you have kind of created that you want to paint as tiles as if they were regular sprites. So you can do some animation stuff with that. What's important is that they're all kind of a multiple of the same size. There are some exceptions to this, but by and large, you kind of want them to be a multiple of whatever grid size you end up working with. So let's start by creating a tile set here. So if we go over to the right hand side, you'll see this tile set property. You can see that it's empty here. So we're going to click that drop down and add a new tile set. Now there's 4 different types of shapes that you can have for your tiles. You can either have square, isometric, half offset, square, or hexagon. The half offset, square, and the hexagon are really similar. They both lay out in a hexagonal structure. The difference is whether or not you want your tiles to be in a square shape or a hexagon shape. We're not going to be worrying about anything but the square shape for now. The concepts that we're going to be covering today are going to work for all of them regardless. But if you want some specifics, I've got other videos coming for that, so stay tuned for that. So from here, we've got our tile size. So this is the most important thing for you to be setting up front, is what multiple of tile size do you want to have that's going to govern your entire tile set. These are typically done as the same value. So 16 by 16, 32 by 32, kind of depends on what the size is of your screen viewport, but you don't have to have them as a square. They could be rectangular if you wanted them to be. So right now it defaults to 16 by 16. There's nothing stopping me from going 16 by 32. So we're going to create our first tile set source, but before we do that, we do need to set our tile size accordingly. If you're following along with the example assets I've provided, they are 64 by 64. So we're going to go over here into our tile size, and we're going to change the 16 by 16 to 64 by 64. So we're all good there. Now we can come down to the bottom, and right next to where it says Tile Map, there's now a TileSet tab here, and so we can click on that. It's going to say here that there's no TileSet source selected, and so those TileSet sources show up on the left-hand side here in this darker area when we have some created. So in order to create one, we click on this plus sign, and it's going to prompt us for Atlas or Scene Collection. As a reminder, that Atlas is kind of like a sprite sheet. It's a singular image that has a bunch of different tiles laid out on it in a consistent grid format. So if we click Atlas, we're going to do that. It's going to prompt us for a resource to add. If we hop into assets here, we have terrain square.png, which is containing our example images here. So the first thing that comes up when we do this is going to prompt to see if we want to automatically create tiles in the atlas. So if we have tiles that are following this 64 by 64 and are not going to be multiples of this, this can be a really easy way to automatically create all of them. So in this case, we're just going to hit no so that we can go through the process ourselves. But I'll show you what it looks like afterwards when we hit yes and it automatically fills everything in. So we're going to hit no. Now, in the bottom here, we now have a tile source, which is this terrain square.png. And so whenever we add new atlases or scene collections, they show up here on the left-hand side. So the first thing we need to do is define our tiles themselves. So in this main window here, we have something that's called base tiles. So if we zoom in here, this is essentially the picture that we were, and the sprite sheet that we loaded. We can see a little bit of a grid here, and so this corresponds to the 64 by 64 grid that we defined over here on the right hand side with our tile size. Now if we need to override this for this particular tile source, maybe these are 128 by 128 or a multiple thereof, we can change this texture region property here. We also have a few other controls here. In this case, we don't need them, but it's important for us to be aware of what they are. So this margin gives us an offset from the top left in order to kind of shunt over a certain number of pixels to the left and down. And this can be used if your tile sheet or your sprite sheet came with some attributions at the top. Particularly for free resources, you can see that. Or if there's just like a little bit of a border around your atlas, you can easily trim them off with the margins. So this is essentially the margin around the entire sprite sheet. Now separation is similar, except it's kind of like margins around the individual tiles. So this is how many pixels may be between individual tiles. So if you have a sprite sheet that has spaces in between each individual region, you would need to set this as well. In this case, neither of those apply to us. So if we want to enable particular tiles, all we have to do is come over here, make sure that we have setup selected here. And if we click on each one, it turns brighter. And so that means that these are now enabled. We can also just click and drag and we can fill all of these out. Now, if we had one big tile that we wanted to add, I'm just going to disable these here really quickly. Let's say that this block of 2 by 2 was one big tile that we wanted to treat as a unit. I can hold shift and click and drag across these, and it's going to create that as a singular tile there. In this case, I'm not going to do that. I'm just going to undo that and select the 4 individually. So by doing this, what I've done here is I've selected all these tiles and said these are now part of the eligible tiles that I can draw. There are 3 spaces on this sprite sheet that are transparent. I deliberately didn't select those. I could, however, there's nothing stopping me from doing that. If I know that something's going to be there and I'm going to put something in afterwards, I could select it. However, at this point, we're not going to see anything. We've got that checkerboard pattern in the back. I'm just going to delete that as a base tile so we don't get confused. Okay, so we've talked about the sprite sheet configuration. Let's now take a look at the configuration for an individual tile itself. So if we hop over to the select option here, if we click on one individual tile, it's going to give us some basic information about it. So first, it gives us the atlas coordinates. If we needed to move something around, we could always adjust it here and kind of shunt it over. Also, if we didn't want to click and drag in order to select tiles, we could define the size in the atlas here. If this atlas was animated, we could use this animation section and we could define our animation settings. And we'll take a look at that in a moment. Now the rendering section is very similar to what you'd see under a canvas item. Our texture origin is used in order to kind of offset things if we need to define where that offset is. So if we bump this 10 pixels off to the side, you can see that all of these base tiles get these red plus signs. And this one is now this kind of black-blue inverted look to it. And that is an indicator that the texture origin, where the center point is on this particular tile, is a little bit offset. Modulate, now this is exactly the same as what you'd see on any canvas item. Same with material, exactly the same logic. Now your Z index, this can be used in order to adjust the relative Z positioning in comparison to everything else. If you need something to appear behind or in front of something, that's what we would use the Z index for. And now the Y sort origin, not super important when it comes to square tiles, but becomes potentially important when we're dealing with isometric. And we'll take a look at that in the isometric video. Now the terrains and miscellaneous, we're going to take a look at those in a little bit. Hang tight on those. So we've taken a look at setup and select. Now let's take a look at the paint options. So the paint option gets used in order to apply a set of settings to multiple tiles really quickly. Sometimes this is going to be collision masks, which we'll take a look at in a moment. It can be used for navigation as well. Or it can be used to just apply various settings quickly across multiple tiles. So if I wanted to, as an example, adjust the texture origin across 5 or 6 different tiles, I would first define the value that I want them to go to, such as 10, 10. Nothing has changed yet because I've first defined it. Then I click on the tiles that it applies to, and it changes each of those texture origins based on the value that's set here. So we define a paint property, and then we click on the tile in order to apply it. I'm just going to reset those values back to the defaults because we don't actually want to change that for now. And so I'm just going to hit undo and set that back to 0, 0. Now these tiles are pretty static, but there's nothing stopping us from having animated tiles. We can just create a new atlas, bring in a sprite sheet that we would have created using something like Sprite, drop it in, and then have our tile animate automatically. So I'm going to do that here. I'm going to bring in a square animated tile, drop it in. We're not going to automatically create tiles in the atlas. We're going to define these ourselves. And so we're going to select the first tile that's going to represent our animation. From there, we go into select that first tile, and then hop into this animation section, down into frames, and then select add element until we've added the elements that we want. You can then define how fast you want each tile to move. So that's how many seconds are spent on each tile. And you can also change the speed of an individual tile. So you could have this whole animation take a total of 4 seconds, but if you want, you can speed this up by a factor of 2, and the whole thing will complete in half the time. From here, we have this, and we can drop this onto the map just like any other tile. We select that square animated tile, and then select our base tile, and then click. And if we look, we can see our little flower is animating back and forth. Now, because of how these are set up, they're always going to be animated at the same time. So I can draw a big bunch of them. They're all going to move all at the same time. They're all going to be perfectly in sync. If we wanted to change that, we're changing it at the tile definition level. So if we hop over into our tile set, we can see that this mode is currently set to default. If I select random start times, you're going to see that they're all going to be a little bit offset. Now, they're not offset by frame, they're offset just in terms of a random time for the total duration of it. So they're not really going to be in sync. If you wanted to have a bunch of tiles that were the animations were still in sync, but they were offset by 1 or 2 exact frames, you would need to create new atlas definitions for that. We've got enough set up now that we can actually start working with our tile set that we've defined. We can actually start painting some of this on. So let's do that now. Hop over into the tile map tab. If you're not seeing it here, make sure that your tile map layer in your scene tree is selected. Remember when we were back here previously, it said that we didn't have any sort of tile sets available. Now we do. We've now got our square terrain. And there's a bunch of different controls that we can use here. We have a selection tool, which can be used to kind of click and drag and select a subset of the tiles that are already down on the ground. We have a paint tool, which lets us draw tile by tile what we want. There's a line tool, and this lets us draw a given tile in a straight line. There's a rectangular tool, which lets us draw boxes, and then a bucket tool, which lets us fill in a contiguous area. This can be used for, say, if you drew a shoreline, you could select your water tile and you could fill in the whole water area. This also has a picker tool. It's an eyedropper if you've worked with paint tools before, selecting the specific tile that you click on so that you can use it in the future. And then there's an eraser tool here. Now this eraser tool is like a modifier. We'll take a look at that one in a moment. And then we've got some adjustments here where we can rotate, we can flip, and then a randomization one. So let's start from the beginning here. Let's just grab our paint tool. So this, the pencil icon, and if we select one of these in the middle here, we can click and drag and we can draw however we want. We can pick another one here. We can draw a line. We can grab this square, select something else, click and drag, and it's going to overwrite what was there. Now, if we have a section, we can just scroll it with our scroll wheel here. If I draw a box here, I could fill this in with that paint tool again, and it will fill it in. That eyedropper tool, no problem. I can quickly click on the other one. Notice how it deselects the moment I click on something. And I could fill all of these in if I wanted to. And now that eraser tool, if I select this, I can use any of the previous tools here and have it act as an eraser instead of applying the changes. So I can take the rectangle tool and I can click and drag and remove a section. Or I can take this line, click and drag, remove a section. Or go across here, individual pencil icon, remove individual tiles, and I can just click on the eraser afterwards in order to turn it off. These rotate tiles can be useful as well, not in this case because we have a tile map that we would be working with, but if I was to draw one of these icons, I can click on the rotate and have it paint one way, rotate it again, flip it again, flip it again, and so forth. And so if you have a limited number of tiles available in your atlas and you need to do something like this, you've got those available. Now this dice icon is used for randomization. So where does this come into play? Well, it usually comes in if you're painting a large area and you want to select a subset of tiles and somewhat randomize the output there. So we can easily do this. To demonstrate this, I'm just going to use this area fill, and I'm going to select a few tiles here and have them randomize. So I'm going to select the 4 corners here. And so we do this by shift clicking the tiles that we want to have randomized. Now we can select from multiple tile sets if we wanted to, but we can do this like so. And if we click on the place random tile here, this die icon, it's going to give us an option here for scattering. So what this scattering does is the higher the number, it reduces the likelihood that it's going to apply a change there. So if we set this to 10 as an example, and I select 4 of these values here, it applies about a 1 in 10 chance or so. We can increase this. This can go up quite high. If we make this 20 or so, it's going to apply less often, and so on and so on. So if you wanted to apply a base green texture and then apply some grass kind of here and there, and you just wanted to randomize it, this is a really good way of doing so. So we skipped over a few options under the tile set. Let's go back to those. Specifically, we skipped over physics, terrains, navigation, and custom data. Let's take a look at those here. There's no options here for physics layers, navigation layers, or custom data layers because they need to be set up at the TileSet layer, not at an individual tile source. If we look over on our right-hand side, we can see physics layers, terrain layers, navigation, and custom data layers all defined here. So let's take a look at those. Physics layers are used to define collisions for your individual tiles. So if you've done this with collision body 2Ds as part of your scenes, this is working with a similar concept. In order to do this for the individual tiles, we need to define physics layers to work with. So we define this physics layer. Unfortunately, physics layers themselves can't have names. Hopefully they'll add them at some point, but your individual collision layers and collision masks can if you'd like to. You can customize these in your settings under your 2D physics layer names. So here you can define multiple layers, and then we can define what that looks like for each individual tile. The definition for a collision layer and a collision mask can be a little bit confusing. How I remember them is that the layer is defining what this tile is. So if I say that this is selected on the ground layer, that's saying that this tile, or at least the selection on the tile that we've got, is ground. The collision mask is what it pays attention to, what it sees coming into its collider. So if we have watercraft as a particular physics layer, it's going to say that I recognize when a watercraft collides with me. So now that we have a physics layer defined, we can see it appear in two different areas. First, if we go to the select section here, right at the bottom, we can see that there's a physics and physics layer 0 defined. And we can see what this looks like for each individual tile, and we can do some modifications here if we need to. We can change the linear velocity and the angular velocity, and we can also define what areas actually have that collider set up. So it doesn't need to be the whole tile, you can define a subset, and that's often what will happen, especially if you're drawing something like a wall, where only one portion of it is really coming into play. You can also do mass painting of them using the paint tool here. You can see that physics layer 0 is now available, and we can define an area that we want, and then apply it to multiple base tiles. So let's start first here. So we're going to select this top tile here. I'm going to click on this. And if you see here in this editor, it now shows the tile and it shows this full area. Now by clicking on it, remember that with the paint tool, whatever value is there gets immediately applied to the tile that you click on. So what we will really want to do is define the shape for this and then apply it. I'll do a quick example here. We're not going to do all of these tiles, but just to give you an idea of what the painting process looks like. What we're defining is what areas are the collider, not the safe areas. We're not painting those out. So if we had a wall, we would want to cover up the wall, but not the walkable area. What we can do here is we go into painting. We can see some controls here. If we expand this out, we have a little bit more of a workable area. We can zoom in and really get down to pixel perfect resolution here. We can also get help with that by selecting this toggle grid snap. If we open this up, there's a disable option, and then there's half grid accuracy as well as grid snap. I'm going to use half pixel accuracy for this. Probably good enough. And then we can work with this polygon just like we would work with any other polygon within Godot. I'm going to click and drag this one option over. I'm just going to do the outer green layer here just as an example. We can zoom in and really target the individual pixels. If I need to add a new pixel, just along this line, you can see a little plus sign that shows up, and I can click and drag that. And there are zoom controls here over in the top left for us to be able to move around. You can also middle click in order to drag the viewport around. Now, if you're working with collision layers, I think it's important to get them really close and accurate. If you have little like sub-pixel or 1 or 2 pixel offsets in between your individual tiles, you're going to notice that if you have something that's colliding along, it's going to get caught on those individual spots. So really take the time to dial those in. That looks pretty good there. I'm happy with that. And so I've defined that for an individual field. And if I click on this, it's now been applied. It is a little hard to see here, but you can see that there is a slight different color there. Now I want to essentially apply the same thing to the other 3 corners that have been defined here. However, I don't want to redefine this every single time. What I can do is I can go into this drop down here, this little kebab menu, and I can rotate right or left. And I can, every time I do that, I can just adjust by 1, click on the tile I want to apply to, rotate right, or press the R key, click on the tile I want to apply it to. One more time, press R, click on the tile, and now I've applied that to all 4 corners. And so there are a lot of tiles here that we would need to go through, but we can simplify some of the process and have things be consistent as long as we have one that's good we can apply it to the other 3 really easily just by rotating or flipping. So now that we've applied that particular physics layer, that exists for all instances of where that tile actually is. We don't need to go through and redraw any of those tiles. This definition travels with the tile source. It doesn't need to get repainted. Any sort of custom data is really tied to the reference to this tile. So if it's used in 20 areas, all 20 areas automatically have that. Let's move on to navigation layers next. They're essentially the same thing as the physics layer in terms of how you interact with them. These are just used for navigation purposes. So if I open up navigation layers here in our tile map layer, we can add a new layer. This defines the navigation layers just as you would be working with regular navigation functionality. Again, if I hop into the select section, you can see that navigation is now available here. And we can define a polygon. We could copy the same polygon, or we could create an inverse of it. And we would go through the same process of painting our navigation layers onto each tile. These may all be walkable. Maybe in that case, we can hop over into our paint section, hop over into navigation layer 0. By default, the entire thing is selected, and I can just go through and click on every single tile. Or I can click and drag, and wherever my cursor ends up, it will cover them. By doing this, what I've said is that all of these tiles, the entire sections of all of those tiles, are all navigable for our navigation server for navigation layer 1. The last piece of logic that we're going to run into for tile sets is the custom data layers. So custom data layers let you set custom data for each individual tile in your tile set. So we can create this, we can define a name for it, and this could be power level, this could be is in a wild area. It could be really any particular piece of data that you want to track for each individual tile. You could even define the data point that it could be. This supports any built-in property that's there, or you could have it set as the any value and you could define it custom that way. Lots of options here for you to work with. And so really this depends on what you want your tiles to represent. I think it's worth pointing out that the custom data layer information is tied to the tile set definition, not what you've painted on your tile map itself. So if I have custom data applied to this particular top left tile and I paint and paint and paint, all of these all share that same custom data value. They don't get their own individual values. If you're looking to track custom data for the tile that's sitting at -5.2 and have that be different than the tile that's at -1.4, you're going to need to implement that in your own code. Tile sets don't have that kind of granularity. They're really designed to that this particular tile is going to be exactly the same in every instance that's there. Anything that's going to be custom on a per coordinate basis needs to be owned by your application code. It's not something that tile sets support. Now, if we're painting large areas, what we may find is that selecting the individual tiles for every single possible option that we want is going to be a little bit frustrating. We may want to repeat the same values over and over. That's where patterns come in. What we can do is we can draw a set of tiles and then we can select them and we can drag them in as an individual pattern. So as an example, if I select these 3 in my tile map and I put that box there and I put that box there, I'll just create a set of 4 squares here. I can then take our selection tool, select all of those, and I can hop into the patterns tab here and I can select a big chunk of tiles and I can drag those into the pattern area, and I've now created that as a reusable pattern. I can now paint that with our paint tool by selecting that pattern, and I can easily apply that over and over. So if you have a set of tiles that you want to constantly have, you can create it once and you can reuse it over and over. Now, it is worth noting that you're still just treating this as a copy paste and you're kind of creating duplicates of those tiles. If I wanted to change this particular pattern, it's not going to magically update all of the areas that I'm using it. That's really, you'd have to redefine it and you'd have to reapply it everywhere you wanted it to. The final piece of useful painting functionality is this terrain section, and we haven't worked with terrains yet. We've been ignoring this terrain set option here over on the right hand side. And so let's take a look at that now. Now, terrain sets are used to quickly draw smooth terrains by defining edges and corners and how tiles link together. That's really what it comes down to. So let's do that now. So we're going to create a new tile set, and we're going to create a new terrain. And you can create multiple terrains within the same terrain set. Now, there's one option here for each terrain set, which is how the matching takes place. You can either match on corners, so the 4 corners of a square. You can match on the sides, so the middle parts of them, or you can match on both. The default here is to match on corners and sides, and so that's what we're going to work with here. So now that I've defined a terrain set and I've defined a terrain, I can now define which tiles are part of that terrain set and then define how they connect together. So to do that, I hop over into our tile set definition, go into paint, select terrains, select our terrain set 0, and then terrain 0. Now, the first thing we want to do is select which tiles are going to be part of this terrain set. And so I'm going to just start with these top 9, and then we're going to define how they connect together. So when we click on each of these 2 edges, what we're saying is that this is allowed to connect when those edges are complete. I also want this corner as well. We're going to accept that. And I'm just going to go through here and define the rest of these. These are all kind of repeating. I just want these to kind of connect on the beige area here. Now the center one, this is allowed to connect on any of those corners. We don't need it to connect in the center there. And so now with this, I can hop into our tile map, select terrains, select terrain set 0 and terrain, and then we get this option here called connect mode. And this lets us draw an area and have the terrain set will attempt to automatically select the right tile for the job. And so if I select our rectangle tool and I draw a square, we're going to notice that it picked the right edges and it figured it all out. Now it's not perfect. You can see that in this case, hey, this tile is kind of lacking something in the corner because we didn't really define a tile for it. We're going to need to do that if we want something like this to work properly. Let's take a look at our tile set. I did provide a few that are going to work for something like this, and we can see that down here we have the exact right tiles for this. And again, I'm going to select those. We're selecting everything but that inside corner. Now, armed with that information, the terrain set builder should be able to handle something like this, no problem. If I draw that out, you can see that it's been able to fill that in. And we could adjust these as required, handles that inside. And so this is a really easy way to maybe build out a room really quickly. There's nothing stopping us from knocking these walls down at a later point if we wanted to put something else in, but this gets us going really far. Now the final thing to take a look at is the rendering and the occlusion layers. So this gets used for light blocking. So if you've ever worked with light sources and you want something to block light, such as maybe a wall, we can use occlusion layers in order to do this. This works off of the exact same light masking functionality that you've seen elsewhere in other nodes. Same concept for painting as well that we've seen in the physics and navigation layers. We hop into our tile set, look at occlusion layer 0, and we could again then say which areas block light. And that's it for TileMapLayers. Whenever you're working with them, you're going to be using some combination of what we outlined here. You're either changing your tile size or laying out more physics layers or adding custom navigation. Everything is just building on the same building blocks that we've outlined here. Doesn't matter what tile shape, doesn't matter what other environment that you're working with them, it's all about the same. Thanks very much for watching. If you have any questions, leave them down below. I'll be happy to answer them. And if you're interested in how to work with isometric tile maps, check out the video over here where we go into specifics for that. Thanks very much. We'll see you next time.